All right. Well, I hope everybody had a good 3-day weekend. We actually have a lot to do in a short amount of time because next Friday, the 1st, is the end of the second grading period. Okay, thanks, sir. All right. And I've actually got a focus activity already put aside for you. There you go, Eli. There we go. Okay. I'll take care of that in just a moment. Okay, so the big item, of course, is going to be on Monday the 28th. You've got a second exam. It's going to cover material from this week's lesson. We're going to be talking about evaluating trig functions on the unit circle. Excuse me. Now, I also went ahead and put some review material on there, such as arc length, area of a sector, just like focus activity, linear and angular velocity. I am going to allow you to use a 3x5 index card. So it has to be a 3x5 index card. Can't be a 3x5 piece of paper cut out, but you can write whatever you would like on it, front or back. Now, because the main topic is evaluating trig functions on the unit circle, maybe you want a miniature unit circle created on that index card. If you feel confident without it, there you go. You don't have to worry about it. But anything you want to place on that is going to be fair game. Don't forget, tomorrow morning is the deadline to retake the first exam. You just need to have the 3 previous assignments done, those being arc length and circular motion, right triangle trig, and angles and their measures. Okay. On Friday, we're going to have ourselves a CFA quiz over this lesson, trig functions on the unit circle. So what's that mean, CFA quiz? I mean, multiple choice on the Chromebook. Okay, so hopefully that shouldn't be too bad. The unit circle projects, that's still available on the website. I don't know if anybody started to work on those over the weekend. It's optional if you're interested. It's due by Friday. I've got copies of the rubric over here. I'll show you again on the website when I get to it in just a minute. But if anybody has any questions about that, please let me know. I'm going to record it as an exam grade. So if your average is a little lower than you would like, that could potentially be a really easy way of boosting it. Happy Minutes, we are going to begin those on Thursday. And we're basically going to be doing it every single day for probably about the next 3 or 4 weeks. Every one of these is going to be for a grade. So we're going to start off real basic with just the trig functions themselves in terms of opposite, adjacent, and hypotenuse. Then we're going to move on to providing a triangle where you give me the ratios. You'll find a missing side, give me the ratios. And ultimately, we'll get to evaluating trig functions on the unit circle. Okay, so those are going to start on Thursday. Just kind of give you a heads up, I'll mention this, it'll be on the website. But next week, not this week, next week, starting on Monday the 28th, there won't be any morning tutorials. Tutorials are going to be after school next week. Again, not this week. They'll go from 3:55 to 4:20. I'm going to be in the dining hall morning next week. That's what my duty is. So if you do need to find me, I'll be down there in the cafeteria, the new cafeteria. There's also something tomorrow, in case you haven't heard about this, Stop the Bleed training. Anybody not heard about that? Okay, so let me go ahead and show you this email very quickly. This was sent out a little while ago. All right. So this is a training that by law we have to have every year, and it looks like, according to the email, they're going to be training 40 students at a time. But the freshmen are going to be called at 8:20, and they'll go to 9:04, sophomores 9:14 to 9:58, juniors 10:08 to 10:52, and then seniors and anybody who missed a previous session will go ahead and start at 11:02 down in the dining hall. All right. So because it's starting at 10:08, and we're right now at 10:11. The juniors are going to be pretty much missing this class tomorrow, so I would encourage you, definitely look at the website, look over the notes. If you have time, watch the video, but definitely come in if you have any questions, because some of this material is going to be on the exam Monday. All right, so any questions about the Stop the Bleeding training? Okay, so that is happening tomorrow. If we go over here to the website, here's the unit circle project. If anybody's interested, again, just let me know. Now, if you look at the current week, 1021 to 1025, again, we're to the point where I'm not copying the homework assignment anymore, but I'm still encouraging you to do it. The homework assignment for this lesson is going to be due on Friday. So if you come over here and look at the notes, trig functions on the unit circle, you'll find the blank notes. Then you have the full notes. And then the very last page is going to be your assignment. So on this one, you would only have to work the circled problems. You don't have to work every single one of those. All right, so if you just want to copy those down or if you want to print it off, completely up to you. But remember, for next week, that second exam, if you're wanting to retake it, you would have to have this assignment done. All right, so that is available to you. I also went ahead and did this because we're in kind of an unusual circumstance with this being a short week. You know, the 6 weeks is only 5 weeks long. We're pretty much going to be finishing up very quickly. I did go ahead and post the answers. So if you're not able to come in for tutorials, you can check yourself, see if you're doing all right. And if you're not, I would encourage you to come in. And then the ideas that we're going to start covering today, reference angles, evaluating the trig functions. If you're looking for some extra problems and you haven't had the opportunity to download the digital textbook yet, I've got this here and the answers are immediately following. Okay, so there is a lot of information coming your way today. Does anybody have any questions? Okay, well, let's go ahead and get to it. First focus activity of this second set. Now remember, we've already taken care of numbers 1 through 4. This is number 5. So with next Friday being the end of the grading period, we'll be turning them in next week. We'll probably only have 3 in this set. So numbers 5, 6, and 7. Okay. But find the area of the given sector. Okay. Does anybody remember off the top of their head what the area formula was that we used? Hey, Will, what do you think?
It's theta out of 360 times pi squared.
Okay, so you can absolutely do that. Let's go ahead and run with the formula that we were using. The 1/2 times the radius squared times theta, where theta's in radians. Now, if you want to go ahead and find the area by using another version of the formula, that's perfectly fine with me, as long as you're able to perform this task. That's all I'm interested in. Now, as part of the exam on Monday, I did go ahead and throw some review items on there because I didn't include them on the previous exam. There is going to be an arc length or an area of a sector problem, and I did go ahead and put another linear and angular velocity problem on there. So if you're thinking about, what information can I place on my index card, maybe these formulas, maybe how to find linear and angular velocity would be a really good idea, along with the unit circle that I mentioned. But let's go ahead and just plug in. So 1/2. Now I know the diameter is 21.4, so what's the radius? 10.7. There we go. Just take it by 2 squared. Now, I would need theta in radians, so I have 146 degrees. I'm not going to convert this separately. I'm just going to go ahead and convert it as I determine the area that we're looking for. So I have the 146 degrees. How do I change degrees to radians? Pi over 180. There we go. Pi over 180 degrees so that those degrees cancel. So all I have to do is take this product and it should give me the number of square kilometers that my sector represents. Okay, can anybody help me out with that? What am I looking for? There we go. If you were to go ahead and type it in, 145.9, because that's where we're looking for the nearest tenth. So 145.9 square kilometers. Okay, good. How many people had that done before we started? Perfect, 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 perfect. Now, just to throw it out there, this one did not want me to find arc length, but let's say it had. What was the formula we used for that? Radius theta. So the radius, again, times theta in radians. There we go. All right. Well, good. Go ahead and put this to the side someplace. You'll get focus activity number 6 on Thursday, and Mr. Yacht is scheduled to work that with you. Okay, so he's going to do that. And he also has I believe, a 10 or a 15-minute little exercise he wants to do with you as well. Okay. So our unit circle. How many people took that extra long weekend to go ahead and practice it? Hooah! All right, so many hands going up. Awesome. I would encourage you to take a look at it. Make sure you know the patterns. Okay, you feel comfortable with it because we have that test coming up. But let's just go ahead and get started. Now you'll notice I'm not providing you a full copy of the notes, but the main definitions and ideas, like anything that would appear in these boxes, I did go ahead and provide that to you here. The actual examples, like this one right here with -4, 3, those are what you'll need to go ahead and copy into your notes or on a piece of paper, wherever you want to go ahead and do so. And just remember, we talked about this previously, you won't have time to copy it word for word, and that's fine. Summarize it, get the idea, okay? And if necessary, the notes are posted on the website. You can go back and fill those in at your convenience. So let's see here. Trig functions of any angle. Let theta be any angle in standard position. What does that mean, standard position? Okay, so Andrew, where do we start rotating? Well, not from a quadrant, but it's border of the first quadrant. What axis? The x-axis, there we go. So whether it's counterclockwise or clockwise, that's what we refer to as standard position. And let's say we have a point, x comma y, on that terminal side. Now remember, the terminal side is where we stop rotating. Okay. Let r represent the non-zero distance from P to the origin. That's my radius. So that is the radius equals the square root of x squared plus y squared. Hello. Thank you. Eli. So this is just a modified version of the Pythagorean theorem. Instead of a, b, and c, we're now using x, y, and r. And you'll see why in just a moment. So we're taking a shift. We're no longer going to think of these 6 trig functions in terms of opposite, adjacent, and hypotenuse. We still want to know those, but from what we're going to do forward, we're going to think of them in terms of these 3 variables. X, the horizontal distance, y, the vertical, and r, the radius. All right, so if we were to take a look at this diagram over here, let's say we rotate into the 3rd quadrant, theta, whatever that represents. So this is my terminal side right here. And we're saying that wherever the terminal side stops, I'm going to have an XY coordinate on the terminal side. Well, with that point, okay, we know this is a point on a circle. A lot of times it's a larger circle that we don't know is there, but that's perfectly fine. We don't have to see it. Okay. From that point, I'm going to connect it perpendicular to the x-axis, and using the radius, that's how I'm going to create my right triangle. All right, so we're not thinking in terms of opposite, adjacent, and hypotenuse anymore. We're thinking in terms of the horizontal distance x, the vertical distance y, and the hypotenuse, the radius r. Okay, now the reference angle is always that theta that we're going to be referring to. So this reference angle would be right here. Remember, that's created between the terminal side and the closest x-axis. All right, so sine of theta, instead of being opposite over hypotenuse, well, we're now going to say y over r, the vertical distance over that radius. Okay, so the reciprocal cosecant would be r over y, and then you can see the rest of those. I'm not going to go ahead and read them to you. Now, there is one thing important before we get started. You want to be able to make sure that you know in what quadrants the functions are positive or negative. Okay, so how do we know which quadrants sine's going to be positive, tangent's going to be positive? Well, I'm glad you asked. There's a little trick here. If you start looking at your quadrants in the counterclockwise motion, if you remember the sentence, all students take calculus. All right. The first letter of each word tells you what trig functions you're going to be interested in. Now, the one exception, A, actually does stand for all. It's the same word in this case. So in quadrant 1, all 6 of your trig functions are always positive, no matter what. Okay. But in quadrant 2, where it says students, what do you think that S refers to? That's sine. Now, if sine of theta is going to be positive in quadrant 2, what also is guaranteed to be positive in quadrant 2? Okay, what's that? Cosecant. Sine's reciprocal. So cosecant of theta. And there we go. And now we can just continue around the rest of the quadrants. What do you think the T stands for? That'd be tangent. So tangent of theta is always positive in the 3rd quadrant. So if tangent's positive here, What's his reciprocal? Cotangent is going to be positive here as well. Oop, a little too high there. And what's the only trig function that we haven't looked at from the top three? Okay, cosine. So cosine of theta is going to be positive in the fourth quadrant. What else would be positive there? Secant. It's reciprocal. There we go. So all students take calculus. The first letter of each word tells you which trig functions are going to be positive there. Now, this is also useful if you know where a trig function is positive, you also now know where they will be negative. So, for example, tangent is going to be positive in quadrants 1 and 3. So what's tangent going to be in 2 and 4? He's got to be negative. Okay, so there you go. If you know where he's positive, you also know where he has to be negative. Any questions about that? Okay, all students take calculus. All right, well, let's go ahead and get to our first example here. Let negative 4 comma 3 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trig functions of theta. Okay. So I'll give you a few seconds, go ahead and jot that down. And you'll notice I did go ahead and change the point for the second one, but the two examples have identical instructions. So just a way of helping you go faster with your notes, you don't have to copy the same set of instructions twice. So maybe in your notes just kind of make reference that it's the same as the previous problem. Okay, so let negative 4 comma 3 be a point on the terminal side of angle theta in standard position. Find the exact values of the 6 trig functions. Okay, now we're thinking of this in terms of an ordered pair. Remember, we're taking the circle and we're placing the center of the circle at the origin of our xy coordinate plane, right? So what quadrant would negative 4, 3 be located in? It'd be in the second one, right? Because from the origin, I'd have to move left for the negative and then up for the positive. So let's say that I rotate some measure of degrees or radians, doesn't matter. The terminal side stops in the second quadrant. Now, where this terminal side stops, I know that I have this point, negative 4, 3, located on it. Now, remember, this belongs to a circle. But I'm going to go ahead and use that point to create a right triangle. I'm going to drop a perpendicular segment down to my x-axis. Okay. The reference angle theta is what I'm going to use in order to help me get my ratios. We always use the reference angle. All right. Well, we already know 2 of the side lengths of this triangle. Remember, this right here was the origin. So I had to go 4 left and then 3 up. But am I missing something? One of them should be something. Which one? The 4. And I've mentioned this several times today. It's not that I'm saying the base of this triangle has a length of negative 4 units. Don't think of it like that. The negative is simply telling me the direction I would have to go. The length is actually 4 units. We just need the negative because of the quadrant that we're in. Now, we got to find the radius, but hopefully you're going to recognize this as a triple. What am I referring to? Yeah, 3, 4, 5, a Pythagorean triple. So the more familiar you are with those, a lot of these are going to be easier. If you don't know those, you can still use the Pythagorean theorem. So this is a 3, 4, 5 right triangle. Okay. All right. Now, all we got to do, now that we have the side lengths of my triangle, is figure out what my ratios are. So sine of theta, we saw just a moment ago, that's y over r. So y being 3 over r, the radius, 5. Now, you remember one thing we did in the beginning where we labeled the sides as opposite, adjacent, and hypotenuse? You could do the same thing here. If you want to go ahead and label them as x, y, and r, if that helps you out in the beginning. If you don't need to, then I wouldn't worry about it. Now, once I have sine, what do I immediately have? I got cosecant. Okay, while sine is y over r, cosecant is r over y. So what would it be? 5/3. Excuse me. There we go. And that's what it's referring to. Once we have my triangle set up, we just want to find all 6 trig ratios. Is anybody having a hard time? Anybody not sure what I've done? Okay. Cosine of theta. According to my definition, it's now x over r. So what would that be? -4/5. There we go. So the reciprocal secant of theta, r over x. Okay, so 5 over -4, I'm going to go ahead and say -5/4. Because you can put 5 over -4, but when we write fractions, we like the numerator or the fraction as a whole to be negative. So if you're ever given a ratio and you're wondering which value the negative applies to, always think about either where you are, what quadrant, or do you have a radius? The radius is always positive no matter what. Only the legs can be negative. All right. And now we got tangent and cotangent. Tangent of theta, okay, is y over x. Well, what's y divided by x with this triangle? Okay, so -3/4. And what would the reciprocal cotangent be? There you go. Any questions? Anybody having a hard time? All right, well, let's go ahead and try this problem. Now, I changed the ordered pair because I wanted to go ahead and get this in another quadrant. So it's the same thing. Create a triangle using this point, 3, -6. So we don't know how far we rotated, but what quadrant would 3, -6 fall into? The fourth one, because remember, this is the origin right here. All right, so I'm going to start in standard position. I'm going to rotate all the way around, and I'm going to have a terminal side that contains this point. So wherever he stops at whatever angle measure, I have this point 3, -6. Just like we did a moment ago with the -4, 3. Okay. All right. Well, now I'm going to use that point to create a right triangle. So I'm going to connect it perpendicular to the x-axis. Okay. I've got theta here. Now, we know from the origin I had to move 3 right. So x equals 3. Then I had to move 6 down. So y equals -6. Again, I'm not saying that that height is -6 units. The negative just tells me what direction I have to go. The one thing I don't have is the what? I need the radius. Okay, so remember, we are calling this the radius the hypotenuse because this is part of a circle that we actually don't see. We don't need to see the circle, to work the problem, but just keep that in mind. We're dealing with points on a circle here. All right, so hopefully that little expression at the beginning, this guy right here, is going to now make a lot more sense. Okay, so the squared radius is equal to 3 squared plus -6 squared. I'm just going to go ahead and plug it directly into the Pythagorean theorem. So what's 9 plus 36? 45. So r squared equals 45. I would have to do what? Take the square root. Now here's the thing. We don't want to go decimal with these. Okay? If it's a perfect square, fantastic. But if it's like this one, we want to reduce it if possible. What would that be? 3 square roots of 5. I can rewrite the square root of 45 as that square root of 9 times 5. 9 being a perfect square. Okay. So r equals 3 square root of 5. Remember, the radius is always positive, that hypotenuse. Okay. So any questions on how I decided on the quadrant, I created the triangle, any of that? Yes, ma'am. Always connected to the x-axis, the closest one. Yes, ma'am. All right. So now I want to do what I did a moment ago. I just want to find those 6 trig functions. So let's start with sine of theta. So sine of theta was y over r. Well, what's the y value here? -6 over the radius we just found to be 3 square root of 5. Now we are going to have to simplify. -6 thirds. That would become -2. But there's also something else I need to do here. There you go. If there's a radical in the denominator, I'm going to ask that you rationalize it. So I have to multiply by a version of 1. Square root of 5 over square root of 5. What would be my final answer? There you go. That would be sine of theta according to this triangle. Remember, theta is the reference angle that we created. Okay. Now let's find cosecant of theta, the reciprocal. Cosecant of theta, that would be r over y. Well, the radius was 3 square roots of 5 over negative 6. So what would the cosecant's ratio be? Would I have to rationalize this one? No, but I do need to simplify. There you go. Square root of 5 over negative 2, so I'll say negative square root of 5 over 2. Okay. And even if you kept the negative down below, I'm not going to count off for that. Okay. All right, and we just keep going. Cosine. So cosine is now x over r, the horizontal distance over the radius, the hypotenuse. What was x? 3 over r, 3 square roots of 5. Again, I'm just creating the fraction, the ratio, based on what the trig function is telling me to do. Okay, so here I do have to simplify and rationalize. Can anybody tell me what my final answer is? Square root of 5 over 5. Now here I just went straight to the final answer. I just mentally multiplied by square root of 5 over square root of 5. Does anybody want me to go back and write that out? Is there anybody who's lost, who's not sure where I'm getting these? Okay. Let's go for secant, which is r over x. All right. Well, that was 3 square roots of 5 over x, which was just 3. So what's this one? Square root of 5. That's easy enough. Okay. And the last two are the easiest of all. Tangent of theta. Remember, tangent is now y over x. We're not thinking of it in terms of opposite over adjacent anymore. So what's the y value? Negative 6 over x, which is 3. So what's tangent of theta? Negative 2. And then our last one here, cotangent of theta. Even though we don't need it, I'm just going to go ahead and put the ratio, x over y. But what's the reciprocal of negative 2? Negative 1/2. There you go. Any problems? Any questions? How we doing? Okay. Cool, 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 cool. Well, there's a couple of ideas I want you to go ahead and understand moving forward. Okay. Now, this middle part right here, you don't have to worry about writing it. You were already provided that on your notes. We already talked about it. It's just the first two and these last two statements. Okay. You need to have those jotted down in your notes. This is very, very important for what we're moving forward with. What do all the x values on the unit circle represent? They represent the cosine of the angle. What do all the y values on the unit circle represent? They represent the sine of the angle. Okay, so this is the key to evaluating trig functions on the unit circle. When you're asked to evaluate cosine, you're looking at the x value. Cosine is the x value. When you're asked to evaluate sine, that is the y value. Cosine equals x, sine equals y. So the ordered pairs, and we're still trying to find the location of these ordered pairs all around the circle, right? And we've always put ordered pairs as x comma y. Well, we're going to be able to take any point on the unit circle now and represent it as cosine comma sine. Cosine is the x value, sine is the y value. Now these top two, this is if you're on the unit circle, if your radius has a length of 1. These bottom two down here, this is if you're on a circle that has a radius other than 1, whether it be shorter or it be larger. Okay, so the x values are r cosine theta, and the y values are r sine of theta. So if you're on a circle that is not with a radius of 1, then your ordered pairs are going to look like this. Okay, but if you are on the unit circle, well, then it's just cosine comma sine. All right. And you're probably wondering, well, how are we able to do that? Well, let me go ahead and show you in just a second. Okay, so remember the whole idea, we're taking a circle and we're placing it on top of an XY coordinate plane. So the center and the origin are the exact same point, right? So let's say I'm looking for the coordinate of a point anywhere on this circle. And it doesn't matter what angle measure I use. Let's say this one right here. Okay. Well, we've already seen using this point on the circle, I'm going to connect it to the x-axis, always the x-axis, and I'm going to create a right triangle where we have the 3 side lengths that we've been dealing with. Okay, x is your horizontal movement, y is the vertical, and the hypotenuse is the radius of the circle. Okay, now theta, the one we're always going to evaluate it at, that's your reference angle. Okay, so let's say given this triangle, I wanted to evaluate cosine of theta. Okay, so I'm going to say cosine of theta equals, well, what's the ratio that we were just introduced to today? It's no longer adjacent over hypotenuse, it's what? It's x over r. Okay, so let's say I wanted to solve this equation like we'd seen in previous lessons. I wanted to solve it for x. What would I do? I just multiply through by r, right? So times r, so those cancel. So I know that the radius times cosine of theta equals x. But remember, we're on the unit circle. What's the length of the radius? 1. So if r equals 1 times cosine of theta, well, that's just cosine of theta is equal to x. You could do the exact same thing for y. Sine of theta equals y over r. So what you'd end up with, instead of an x comma y coordinate, your coordinate is now in terms of cosine and sine. That's why every time we say cosine now, I want you to think x. Cosine is the x value. Sine is the y value. All right. Okay. Now, if we're not on the unit circle, let's say my radius is longer or shorter than 1, well, that's where this one comes in. This is how you'd find the coordinate of any point on a circle where the radius is not 1. Okay. Well, let's put this into practice. Let's introduce an old idea. Quadrantal angles. What's a quadrantal? A quadrantal is when the terminal side stops where? On one of the axes. Okay. Whatever your angle measure is, whether it's in degrees or it's in radians, if your terminal side stops on an axis, that's what we refer to as a quadrantal. So you've got the 4 here. You've got 0 degrees or 0 radians, 90 degrees pi over 2, 180 degrees pi, and 270 degrees 3 pi over 2 radians. Okay, so now we're getting to the main idea of this lesson. We really want to evaluate a trig function with one of the 16 values on the circle. Okay, so here's how this works. The angle measure, and it makes no difference if this is given to you in radians or degrees. You use the angle measure to figure out where your terminal side stops. The ordered pair located where the terminal side stops, that's what you're going to use to get your answer, because the trig function will then tell you what to do with it. So let me explain. Cosine of pi. Let's go ahead and recreate this. Here's 0 radians. Here's pi over 2. Here's pi. Here's 3 pi over 2, all the way back around to 2 pi, right? Okay. So if I start here in standard position and I rotate counterclockwise, would everybody agree that's where my terminal side would be? Okay, that's the first part. The angle measure is going to tell you where your terminal side stops. Now, if we're on the unit circle, the ordered pair here is negative 1, 0. Remember, this is your x value, this is your y value. Once you know the specific ordered pair where your terminal side stops, the trig function tells you what to do with it. Remember, cosine is what variable? Remember, I said a moment ago, when I say cosine, you think what variable? X. Okay, so if I want cosine of pi, well, what's the x value of that coordinate? So cosine of pi is negative 1. And it does not matter if it's in radians or degrees. If I were to go ahead and give you cosine of 180 degrees, well, what's the x value at 180 degrees? It's still negative 1. Okay. Now let me kind of expand on this a little bit. What if I asked you for the sine of pi? There you go. Remember, if cosine is x, sine is what? Sine is y. So the y value at pi radians is 0. Okay. The angle tells you where to find the ordered pair we're interested in. Then the trig function tells you what to do with the x and the y values we find. What if I wanted tangent of pi? Now remember, tangent, he wants the y value over the x value. Well, what's the y value? 0. What's the x value? Negative 1. So tangent of pi should be 0. Would the reciprocal cotangent exist here? No, because cotangent would be x over y. We'd be dividing by 0. So cotangent isn't defined at pi. Is this making sense? Is there anybody confused? Okay, let's try another one. Find the exact value of tangent of 450 degrees. Okay, so I'm in degrees. Again, we just need to figure out where 450 is going to stop me. We need the ordered pair where it stops. So here's 0, here's 90, here's 180, here's 270, all the way back around to 360. Now, if I were to start here in standard position and I rotate it all the way around here, that's 360 degrees. Would everybody agree? But how much further would I have to go to reach 450? 90. 450 minus 360 is 90. So all I have to do is rotate here. So that is where my terminal side is. Okay. So now what's the ordered pair on the unit circle at that location? It's 0, 1. See, that's your x, that's your y. We want tangent of 450 degrees. Or remember, tangent is y divided by x. Well, what's the y value? 1. What's the x value? 0. Whoop. So this one, tangent is not defined at 450 degrees. Now, think about your coterminal angles. Those are angle measures that are different but have the same terminal side, right? So what else is going to stop me right there in that location? Couldn't I go ahead and say tangent of 90 degrees? 90 would stop me in the same spot as 450. Well, it's still not defined there. And what even if I throw in, made it radians instead? What if I said tangent of pi over 2? Does it make a difference? No. Whether radians or degrees, it matters where it stops you and what ordered pair you have there. Okay, you want to try one on your own? Sure. Okay. Try this one. Cotangent of 7 pi over 2. The biggest idea is going to be to figure out where does that 7 pi over 2 stop me? What ordered pair do I have at that location? Okay, so while you guys are doing that, let me go ahead and do this. So that's 0 radians, pi over 2, pi, 3 pi over 2, all the way back around to 2 pi. Now, sometimes it's going to be one of those radian measures that you recognize from the unit circle, one of those 16 points. In this case, it's not. So that means it has to be coterminal. So it's still going to stop at one of the locations we're familiar with. Okay, so if you're stuck, For this type of problem, 7 pi over 2, I would take that improper fraction and rewrite it as a what? I wouldn't write it as, well, decimals okay. I'd go mixed number. Okay. We want to try to avoid decimals with these. Does anybody think they know what the answer to cotangent 7 pi over 2 is? Philip, what do you think? It is 0. It is 0. Where would this have stopped me? Okay, so the bottom, the negative y-axis. Okay, so 7 pi over 2, let's go ahead and run through this. As a mixed number, would everybody agree that's 3 1/2 pi? Okay, now remember, half a rotation is pi, right? So the first thing we got to do is 3 pi. So I'm going to start here. So there's 1. There's 2 pi. There's 3 pi. So that takes care of that. Now all I have to do is rotate an additional half pi. Okay, but remember, pi is only half a rotation. So half of that is just a quarter. All right. Now, what's the ordered pair at that location? 0, -1. Okay, there's my x and there's my y. Now, what's cotangent's ratio? Cotangent of 7 pi over 2. Remember, cotangent wants the x over the y, right? Tangent wants the y over x. Well, the x value is 0. What's the y value? -1. So 0 divided by -1 is 0. Okay. Now, even if I go ahead and use coterminal angles, to get here we use 7 pi over 2, but what would cotangent of 3 pi over 2 give me? Yeah, even though it's a different angle measure, doesn't it stop me in the exact same location? So it would still be x over y. What if I said cotangent of -pi over 2? It would still be 0. Now, all these are radians. What if I went ahead and did it in degrees? What about cotangent of 270 degrees? Still 0, and that's what I want you to understand. The angle measure simply tells you where to stop. It's the ordered pair where you stop that's important. Is everybody okay with this? Anybody having trouble? Okay. All right, so we have reference angles here. This is something that we already talked about. I'm just going to go ahead and bring it up again because it's going to be super important to us now. Remember, reference angles are always positive. And how do we create them? It's between what two sides? Okay, so the terminal and the closest x-axis, as I've got highlighted here. Okay, so the reference angle is always going to be created between the terminal side and the closest x-axis. All right, you just got a little bit more information here to kind of help you out with that. We do have a few of these. Let's go ahead and do one together, and then we'll go ahead and stop. -150 degrees. What's that negative telling me to do? What do we call that? Clockwise. Now, counter is when we rotate to the left. So clockwise, we're going to rotate here. So remember, this would be -90. This would be -180. So -150 would place me maybe right about here. Okay. So it's always created between my terminal side and the closest x-axis. Now, how much further would I have to rotate to get back to the x-axis? Yeah, 30. Remember, the reference angle is always positive. So this guy here is 30 degrees. And there you go. I'll let you go ahead and take a look at this on your own, but 3 pi over 4 would place me in the second quadrant. So the reference angle would simply be pi over 4. Okay. All right, so it looks like the bell's about to ring, so we'll go ahead and stop